Okay, so now in today's video, we're going to talk about functional notation. And so to introduce functional notation, let me explain what we mean by that. There are many different relationships between variables. So we can come up with all kinds of different relationships between two variables. Not all relationships will fall into the category of being a function, right? So, for example, if I write y equals the square root of x, oh, not that one. It's not the one I want. Let's do if I write it that way. This is not a function of x, right? This is not a function. Why? Because again, if y is the dependent variable, x is the independent variable. And that's typically the way we define x and y. So just so you know that. So in this case here, remember what the definition of a function is. It's for every value of x, there is exactly one value of y. Okay, so in other words, in this case here, is that true in this case? And the answer is no. Okay? For example, if I write it this way, then it's probably easier to see. Because when I take the square root of both sides, I get y equals the plus or minus of the square root of x. Remember, when you take the square root of both sides, you have to have plus or minus here. Okay? Because I can take x and put 1 in here. So that means when x is 1, y is equal to plus or minus 1. So that means there's two values of y. Well, that violates the definition of a function. So this is not a function. So, but it is a relationship, right? It does show a relationship between x and y. It's just that relationship is not a function. So, when something is a function, we can use special notation to show that this is a function, and the way we show it is using this notation right here, and we say this is a function of x. So we say y is a function of x, okay? Or the way we say that is we say f of x. Right, so when we pronounce this, we say f of x, okay? So when we write a function, and we know that it's a function, then we can replace y with f of x. Now, y and f of x will represent the same function. It's just that y shows you the values, right? The relationship between the values, x and y, where f of x puts the spotlight on the functional characteristic of it, okay, that it's a function, okay? So for example, if we look at this example here, we're saying that we have this relationship of y and x, and y is equal to 6 times x cubed, minus 5 times x. So 6x cubed minus 5x. Okay? Now, since this is a function, right, we can see that it's a function because for every value of x, we're only going to get one y. So we could rewrite this as f of x, right? Y equals f of x. So we could say f of x is equal to 6x cubed minus 5x. Okay? And it shows that this is a function of x. So look, whatever goes in here goes in where the x's are. So we can substitute in for x. Another thing about functions is that, hey, when we evaluate a function, then we can look at, hey, what's the value of the function at a particular value a? For example, when x equals some value a. So in other words, I want to evaluate the function at f of a. So what does that mean? It means that wherever there's an x, I'm going to substitute in whatever's in here. Okay? Think of a function as like a machine. Whatever goes in will always spit something out. And if you put the same thing into the function, it will always spit the same thing out. You'll never get something different. Remember the definition of a function. So, if I put a in here, that means I have to replace x with a as well. So that's going to be 6a cubed minus 5a. So now let's do it with a number, okay? So let's even get more fundamental here, okay? What if I put this? So remember, this is like a machine. This is the input, right? So this is the input, right? And this is the output. So you put something in, you get something out. Well, what do you get out? Well, that's based on what the machine does, the rule. Okay? So this is what we call the rule. Okay? So, input, well, whatever goes in here, I have to put in place of x. So I'm going to put in parentheses wherever there's an x. And now you can hopefully better see what we're doing here. So whatever goes in here also has to go in here and here. And then we get the output, the answer. So if I put in 3, then I have to put in 3 here, and I have to put in 3 here. If I put in -3, then I got to put in -3 in here and -3 in here, which is crucial, right? When you're dealing with negative numbers, you got to make sure that you include the negative numbers in the parentheses, okay? Or if I have something else, maybe I want to do x plus a, something like that. And I want to put x plus a in here. Well, that means I have to put x plus a in here, and I have to put x plus a in here. So again, that will help you. If you think about it that way, I hope that's going to help you avoid some of the mistakes that a lot of students, when they first deal with functions, fall into. Okay? So other than that, I'll see you next time.